But this one, or if you were doing it, you would need to figure out what you're using, which it is a 3 by 3. But then why am I putting slashes not necessarily every 3 letters? Yeah, the space count. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Oh, I'm going to put a space here at the end, right, to finish him off. So you guys said a second ago it was 1355. 1355, just from matching up with what order it is in the alphabet. Yeah, so 1355, and then T is 20, the space is 0, and then M is 13. And then 5, and then 0, then 13, then keep going. Now the book would write it all weird and awkward and side by side. But you don't have to do that. You could write them on top of each other. Why would you want to write them on top of each other instead of side by side? Because the book would say, you know what, you should take every single one of those little 1 by 3s and multiply this guy by that for the first one. And then multiply this guy by that. And then multiply that. Oh my goodness, how much work would that be? But what could we do instead? I'm going to take a question in just a second, but let me show you what I would do instead. Instead of taking each one and throwing it at the encoder, we're coding it, putting it into code. Instead of going 1 by 1, if I were you, because Lauren, you were asking how to write it, I would actually write it like this. Then we had I need to group it by 3s, not only because the directions said split up into little 1 by 3s, but also my encoder is a 3 by 3. And multiplication is only legal, right, when the number of columns equals the number of rows. So I can't have him be a 1 by 2 or go by 2s or go by 4s, because then that would be a legal multiplication. But if I can get this guy to be all nice and written out as a matrix, where the book would say, hey, you should do this multiplication to each one individually, I'm like, yeah, no, I'm not going to do that. I'm going to make a big old, well, how long did my message end up being? 1, 2, 3, 4, 5 by 3. Sure. I'm going to throw one 5 by 3 into my calculator, multiply it by my encoder, and then I'll get my mixed up message. Yeah. Yeah, in section 8.5. Remember applications? In section 8.5. Remember on Friday, the one that I warned you about was Kramer's rule and area. I said you would be allowed to use your calculator, but I would ask you to write out the formula that you're going to do first. Does that make sense? Yeah, that's why we practiced it a lot about as far as writing it out, but I didn't make you guys necessarily solve all of those determinants by hand because it'd be a lot of work. The non-calculator is 1 page front and back. We haven't really started talking about the test yet, but, and then the non-calculator, sorry, that was the non-calculator. And then the calculator portion is 2 pages, stapled. And this section 8.5, I think everything shows up on the calculator portion except for maybe that weird example we didn't get to cover on Friday about the equation of the line. Maybe it was making something linear. But if Kramer's rule shows up on the test, even though you're allowed to use a calculator to do the work, you only get full credit if you actually show me the little formula. Not like solving by hand, but showing me the fraction and how you found it. You guys throwing this in? Do you see your little encoder over here? Your 3 by 3? You should get out a matrix of the exact same size. It should still be a 5 by 3. Because every letter is going to get all mixed up. I know the first row should be, if you guys have done it right, 13, negative 26, 21. And this shows us why encoding with matrices is so cool. Sometimes numbers will stay the same. Sometimes you'll have like these weird negatives, or they change. And you can have numbers be way bigger than the 26 letters of the alphabet or way more negative. They get changed in lots of different ways. So that someone like a pattern, somebody looking for a pattern in the numbers are going to be so confused because each number got found a little differently. As far as an addition of lots of different multiplications of lots of different numbers, trying to get back to here would be near impossible. Very difficult, at least. What did you guys get for your second row? If your first one matched up. 43? 33. Keep going, Matthew. Jason, keep going the next row.
Me?
Mm-hmm.
Oh, 63, negative 113, and 48.
Should be 18. What should be 18, bud?
That should be 18.
Uh-oh. Who else has it besides these two? Everything else is matching up except for the 18? Matthew, keep going the next row. Jason, does your next row match up?
No.
Uh-oh.
Wait. No. Actually,
Let's-
the
You get an 18? 18. Maybe you inputted something wrong in your message somewhere around here. So then Tyler, keep going. 18 here, and then... Oh. He got off here. Yeah, he got off here. So it's 18, negative 20. Keep going, Tyler. Should have one more, right? Do you guys see how all of a sudden some of the letters now are assigned a 77? That was a 0, and like 56. So it's just messing all of our numbers up. And it seems like it's totally random. It seems like even here, it was like you're an E and you're an E. You're a, I don't even know if you're the same or not. That's so confusing. And even things that do match up, well, actually they don't match up. Does anything match up? Nothing matches up. And there are no zeros. You can't even see the blanks. Like, so confusing. What did we just do? What vocab explains what we just did? We encrypted. We did a cryptogram. But yeah, I would say technically what we would say is we encoded. We put a message. Well, we put a message into numbers, but that's super basic. Then we encoded our message using matrix multiplication by an invertible. Remember, the determinant can't equal 0. And here's why. If the determinant equaled 0, we could still get here just fine. But for any coded message, what do you want to be able to do or have someone else be able to do? Decode it, right? Like if you put in information on an online banking app, like, yeah, you don't want anyone to be able to access that except the bank. Like you want them to be able to access it. If you're depositing like checks via phone, didn't your parents do that? Maybe it's just me. But if like you want the bank to be like, oh, yeah, it's your money and you deserve it and I'm going to put it in your account. Like you want no one else to take it, but you do want the bank to take it. So if you encode it, that's great, but we also need to be able to decode. So what would we do with this encoded matrix to decode? If we multiply by inverse, guys, what do inverses do in general?
Reverse the process.
Undo is what I was thinking, but yeah, it would reverse the process. And it would reverse the process in a way that nothing else could do. Adding, subtracting, dividing, no, we'd be totally lost if we couldn't do the inverse. Ooh. Why did I say the determinant has to be anything but 0? Why can't it be 0? If it was 0, there would be no inverse. There would be no way back. There'd be no way to decode it or to decrypt it or to decipher it. It would just be sent out there and then no one could ever read it. And you're like, well, that's great. Like not even you could undo it. Like you could say like, well, here's what the message was, but that doesn't help anyone. Now, you guys aren't going to have to, I made honors make up their own encoder and their own message, and even they struggled for a bit. I'm not going to make you make up your own encoder. Either I'm going to give you the encoder, or I'm going to give you the inverse. Or I'm going to give you the encoder and make you find the inverse. Wait a minute, if you're allowed to use your calculators on this problem, couldn't you just right now, whatever matrix you just got, the encoded one, couldn't you just say times a to the, and how do we do inverse on the calculator? It'll be helpful for tomorrow. That little x negative one, which is underneath? No, it is where the matrix thing is too, right? My question is, can you not only encode, but also decode? Can you get back to our original message of 1355, 20, 13, 50, 13, 15, 4, 4, 14, 4? You guys back? Uh-oh. Double check. Oh, sorry. Check where you put your encoder. Maybe some of you put that in B. You have to multiply it by the encoder's inverse, not the message's inverse. By the encoder's inverse.
I got the inverse, but you can't plug it in straight with the
Oh, that's weird, Tyler. A times B encodes it the way you want it to. And times. You went to matrix B, right? Not just letter B. If you use alpha B, it wouldn't work. But if you go to second matrix, I don't know. Something went. I was trying to see what you did differently, but I can't see it. 1355. Now, guys, what if, for instance, what if I gave you, instead of a string of numbers with the original message, what if I gave you a string of numbers that was already encoded? And you multiplied by A inverse, and then you got this, and you notice that they're hopefully in between 0 and 26. Probably some zeros in between. I know you know the message is Meet Me Monday, but question, how would you have figured that out on your own if you didn't know what the message began? Or was to begin with? Yeah. Wouldn't you then go ahead and go row by row and start putting letters to the numbers, right? And every time you saw a 0, you would make a space, right? And you would get M-E-E-T space, M-E space, M-O-N-D-A-Y. So I know you knew what the message was to begin with, but maybe on the test I'll give you one that's already been mixed up with an encoder, or at least with the encoding matrix, and all you have to do is multiply by the inverse and then match it up. Maybe that wouldn't be too bad. Any questions on cryptograms, specifically with matrices? Joe? It's an introduction to... Compare the two messages, like the beginning and the end? Yeah. Oh, like how to find the key, like if you're not given the key. We don't go that complicated. I hear what you're saying, but we're just doing like the basics. Yeah. Okay. With that, kiddos, we need to grade section 8.5 and see if you have any questions on things besides the message ones. Because the message ones, like the wording is kind of weird, the directions are weird, so I thought we should just do a full example where you saw what's going on as far as if they say the word encode, you're putting in decode. And what would we call this guy? If this is the encoded message, what would this guy be? Yeah, you could say the original message, but that's more back here. Better, you could say the decoded message. And then who is your A? Did you guys hear me say that word enough? He's the encoder. So there's just a little bit of vocab as far as a decoded message, an encoded message, and then an encoder matrix. And then his inverse, well, I guess you could call that the decoder matrix, but that's kind of awkward. All right, let's go grade. Number 2, collinear, just a vocab. Number 4, cryptogram. Once again, just a vocab. But then you guys had some problems. So, oh, I didn't give you any evens until the message one? Did you guys figure out it was to be or not to be? Now, hold on. Look at what the book did. Isn't this nasty? Like, literally, they took each 1 by 2, and they took each line of the message and multiplied. That would take forever. By hand, even with the calculator, it would take forever. So what should you guys have done instead? What size matrix could this have been? 1, 2, 3, 4, 5, 6, 7, 8, 9? It could have been a 9 by 2. You could have put it in as one matrix and multiplied it by your little 2 by 2, and then you could have gotten the entire message. And then you would have gone 20 is a T, and 15 is a O, and O is a blank, and 2 is a B. You guys get how to get the message once you have the decoded numbers, right? Okay. But if I were you guys, I would have totally done a 9 by 2, not this line by line craziness that the book was doing. So to be or not to be? That was the question. Oh, is that it? As far as evens? Goodness gracious. All right, it's okay. That means I wanted you to be able to and come today with questions, right? So ooh, wow, that took a while to focus. I'm sorry, guys. What questions do we have on 8.5, the odds? 37. Anything besides 37? Those ones too. I'll need you guys to give me numbers. I'm going to get a picture for 37, and then once we finish that example, I'll be asking for one of those ones, Lauren, okay? Number 37 said, ooh, use the determinant to determine whether the points are collinear. What do we know about collinear? Is it about this one? Yeah. Okay, go ahead.
I guess you'll probably answer it while you're doing it. For this one, was it like what we've normally been doing, but it's just in different forms?
It's applied. This whole section is a. This whole section is using determinants, and determinants are the circle crossing.
Oh, okay.
Does that make sense? So kind of like how with vectors, we learned what the dot product formula was, and then we used it in lots of ways. We learned what the determinant was, and this section is having us use it in lots of ways. Well, kind of, except this one, collinear has a very specific meaning. Collinear means that the area between the points, like the rectangle, isn't there. Sorry, the triangle. Yeah. So isn't there a formula for area of a triangle using points? And there technically is this whole like plus or minus 1/2 thingamabob in front. But to be honest, we could move that to the other side. What we're looking at is, well, guys, hold on. How do we make that matrix, that determinant, using 3 points to find area of a triangle? And then that column is all ones. So we put in each of the points in any order. And then we see if the determinant is equal to 0. Now the nice thing is, if this was on the calculator, now there's a question mark. It's saying determine if. So we're asking, is it 0 or is it not? If it is 0, it's collinear. If it's not 0, then it's not collinear. But if this was on the problem, the calculator portion of the test, what could you guys do right now? DET. Yeah, DET of A. What'd you guys get? Was it 0 or was it not 0? Ah, so since the determinant equaled 6, which is not 0, we would say not, right? Uh-oh. Something went wrong, Jason.
Oh, it's determinant of A. Oh, never mind.
Does that make sense? Oh, you did the area and then you divided by 1/2 and then. And remember, if it was an area question, because Jason just kept going with the 1/2, which still showed him it wasn't, 0. They aren't collinear. Right. It wasn't 0. But if I was asking for the area, you guys should never answer a negative number, right? Okay. So the determinant, interesting. The area, but you're not answering area. So you guys gave me the determinant. Okay. I thought for a second you gave me the area. Never mind. But either way, determinant's not 0, area is not 0, not collinear. Now you guys said you got stuck on the messages, so can you give me one? One of the message ones? 40. Well, hold on. You guys are acting like your question didn't just get answered by what we just did. Didn't we just do meet me on Monday and we took the letters and we put them into numbers and then we multiplied it by an encoder and got an encoded message? So wait, what are they asking? Take the message, group them by
So do we just draw the little box, the long box?
the long box, and we're grouping this guy by what? By 3s, by 2s, by 1s, by 4s? By 2s, because this guy is a 2 by 2 and because they tell me make 1 by 2s. So I'm going to group it by 2s. And guys, how do I get numbers out of letters? Use the chart. So C is 3, O is, etc., etc. Now wait, can you guys tell how many rows? Because technically you could be doing this and putting it in your calculator at the same time. But we need to know what size matrix to make. So how many rows do we have? There's 1, going by pairs, right? 1, 2, the space is 1, right? 3, 4, the space is 5, 6, 7. Does that sound right? A 7 by 2? Good. So you could make in your calculator a 7 by 2, and you could put in or start putting in your message. You could say 3, then you could say 15, then you could say 13, then 5, then 0, and you can build or fill in your matrix. And once you fill in the message, what do you need to do to encode it? Multiply. Multiply, like we did in the back of our homework spirals with Meet Me on Monday. So you would make a little, just counting by 2s, 1, 2, to count your space as a letter, 3, 4, 5, 6, 7. I need a 7 by 2 matrix. I can go to my numbers and I can fill in for each letter. And then I multiply it by this little 2 by 2. You can put him in the B spot. And then will the message be encoded? Yeah. Now you could write down the encoded message in a matrix, or if you wanted to be really mean, instead of writing it in a matrix, you could write it like over here in number 57 and 58 and 59. Ooh, they said to decode, but did they give this to us in a matrix? They just gave us a string of numbers. They're like, we're not going to give away what we encoded it with. Well, I mean, besides the fact that matrix is right above it. So guys, what size matrix are we going to put this guy in to be decoded? Split it up by 2s again, because look at him. The only way this could have legally been used is if it was by 2s. So I could make 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows, 7 rows. It's a 7 by 2 again. And I would put in all these numbers, but when I put in all these numbers to my 7 by 2, am I multiplying by A and encoding it, or should I multiply by the directions were helping you? Yeah. Put in this guy as your, for most of you guys, you can put it in as B. Multiply by B inverse to decode. Now guys, should I be going to the board and saying 11 is K, and 21 is U, and 64 is ah? Just kidding. This is the encoded message. I need to multiply the encoder, this 7 by 2, by this inverse to get back to what it really was. And that's why number 58, this one is one that you guys did. You should have paired it up by 2s, and if you guys look at the answer key, you can see that. They paired it up by 2s, except I wouldn't have done them separately. I would have done them all together. They multiplied not by the original guy, but by his inverse. And they actually solved for the inverse using the formula of 1 over the determinant of A. If I had told you guys you're allowed to use your calculator on these ones, so you could just do the little inverse button in your calculator. And when you multiply in 58, you would have gotten 20, which goes to T, and 15, which goes to O, and 0, which goes to a space, etc. Does that make sense, guys? So back here in the one that you guys were doing, number 49, you could write the matrix you get after putting this into numbers and multiplying it by the encoder, or you could be mean and just write the numbers out, not giving away how you got it. Priscilla.
I didn't know how to do 61 because it says using the inverse of the
Oh, they told you you're allowed to, ooh, who's 53 to 56?
Yeah, that's what
What size is this guy? He's a 3 by 3, and this is the encoder. And so down here, I think we're going to be decoding probably with his inverse. Yeah, decoding. But hold on, why are we not going to split up by 2s? What size was that guy up there? So we're going to go 1, 2, 3, new row. So that's row 1, row 2, 1, 2, 3, row 3, row 4. So we're going to make a 4 by 3. We're grouping these by 3s to make the matrix multiplication legal when we go to put this guy in our calculator and multiply by his inverse. So you have to remember, we're multiplying by the encoder to get it encoded or by his inverse to get it decoded. So in our notes, once again, we multiply by A to encode it, but then we multiply by the inverse to decode it. Is that cool? All right. Does that make sense, the grouping, like when to do by 2s or by 3s?
I don't understand if we need to go back to the other.
Yeah.
Oh, sorry, the note actually.
Oh, sorry. Yeah.
So on the left side it says including matrix and then including excluded. Where?
Oh, this is the book being awkward and saying we're not going to take the whole message like we did. We're going to take just a piece of it and say, hey, I'll throw you in and get you mixed up. And then they would have to come back and say, now it's time to throw you in and get you mixed up. But we just did it in one big old matrix to get one big encoded matrix. Yeah. And you just have to think about splitting up by 2s or by 3s, what size to make the matrix. But otherwise, you're good. Yeah, so the book made it look way worse than it had to be, which is why in that number 58, I was like, ugh, look at that. That's disgusting. It could have been one big old long matrix times this only one time. Would have been so much easier. Anything else from homework? All right, kiddos, I'm going to give you some particulars about the test, but I'm going to give you a little bit of time to write down the test review. Oh, there's a comma missing. That's really awkward. Sorry, guys. Between 135 and 141, there should totally be a comma. Oh my goodness, these are super long and disgusting and so, well, hold on. Aren't some of them just saying like, hey, what order is this guy? Or who is this entry? Or solve for x by setting these two equal? Or tell me the row operation, how to get? Or let's add these two. But as you guys go through your homework, you need to be paying attention for, or to, did I need a formula for this? If I was to do this by hand, would I need to have something memorized? Because you guys don't get a formula card tomorrow. You don't get a half sheet. Yes, on part of the test you get to use your calculator, but even then there are things like area where you need to know the formula to plug into your calculator. So you got to be careful on that. So while you guys are in your homework spirals or your notes, wherever you are, and while you're either in your notes at the end or in your homework spiral at the test review, if I were you in a colored pen, maybe write down some hints. I'm going to start hinting in about 30 seconds, so get the assignment down. And then wherever is best for you as far as studying, should you put it in your notes and then find examples for each of the things I say? Should you put it in your test review and then be on the lookout whenever a problem comes? You're like, oh, that's what she meant by saying. You know what I mean? Find a place to put your clues and your hints as to what to study. Let's start with the non-calculator piece. I think that would scare most of you guys the most, right? The non-calculator piece. Question, if you have two matrices with an equals in between, what can we say about every single entry? So if you have a little baby side with like variables and then another side with numbers, what can you make and then solve? Little baby equations. You are going to have to do a multiplication of matrices, at least one, maybe more than one, by hand. But the first thing you have to ask yourself, is it legal? And so remember, how do we write the order of a matrix again? First we count how many rows, and then we count how many. So we go down and then across, right? So like a 3 by 2 or like a 1 by 5. And then we compare the two, and what has to be true for the multiplication to be legal? Good, the inside numbers have to match, right? And when the inside numbers match, what do the outside numbers tell us? How big it's going to be. So, oh no, go ahead. So when you have your orders like a 1 by 3 and a 3 by 2, remember these two need to match. And then these ones give you the answer size. Now, how do we multiply? Remind me, what's that little phrase we use? Cross down, right? Yeah, and we're getting fingers out because as one goes across, the other one goes down like we practiced in class, and they have to measure up, right? But we multiply, and what happens when we switch? Multiply, add, multiply, add, multiply, right? We put it all together in one number every time we do a cross down. We talked about orders. We talked about, you guys are okay with adding and subtracting matrices, that sort of stuff, right? What if I ask you to do a determinant of a 2 by 2? What's a way of remembering that one? No. You're thinking inverse formula. Inverse formula is 1 over determinant times, and then you flip, and then you switch. Main minus opposite. Or there is a formula, Matthew, you always say this one, AD minus BC, which is a part of your inversey thing, but determinant is just AD minus BC. And how can you see a determinant like in a problem? Maybe it says the word determinant, maybe it says DET, or absolute value bars show up. Remember those determinant ones where x's showed up and we had to like solve a little equation with factoring? One of those. There's going to be one like section 8.1. There's going to be one like section 8.1 with an RREF, but just a hint, it's small. So you're going to have to do some row operations, but it's going to be a baby one. It's going to be a little one. So you could check it with substitution or elimination and make sure you're right. But there's going to be one where you take a system of equations into a matrix, and then you get the ones and the zeros and the zeros and the ones. No, always start with the ones, then go zeros to get your x and to get your y. Lauren?
Is it where you have to go all the way? Like you have to get the zeros on top and bottom?
Yes. Yes. Yeah, go all the way to the identity matrix. Good. You're going to have to find an inverse by hand, but it's going to be a little baby one, just a 2 by 2. And there were like 3 different ways of doing it by hand. So just make sure you show me everything. Like if you guys remember, Matthew saw a pattern to some determinants, but then we realized there actually is this little 1 over determinant like Lauren was just saying. Make sure whatever way you choose, with little A, B, C, D, or with like the double E augment, or with the formula, whatever way you choose, you show me how to use it. And then there's going to be some determinants by hand also. A 3 by 3 and maybe even a bigger one. But guys, if I'm giving you big determinants, doesn't that mean at least there are going to be some zeros in there to make it easier? Okay, calculator part. I'm going to give you a big, huge, nasty system and see if you can use the RREF to go all the way without doing anything by hand. On the calculator portion, RREF, doesn't that get you your identity matrix and x equals y equals z equals? RREF, using your calculator to do like 8-1 problems. You need to know how to multiply in your calculator. You need to know how to do determinants in your calculator. RREF in your calculator. Your area formula. The collinear.
What is the area formula?
It was just up on the board and now it's not. Plus or minus 1/2 times, you guys tell me. One of the points, another point with 1 1 1s on the end. Yeah. And the points can be in any order, doesn't matter. Hey, good thing you guys asked me about that collinear thing. There's a collinear thing, but you get to use your calculator. Then last but not least, you have an encoding to do. And then maybe you get a mixed up message. You get a cryptogram. Maybe the bonus is to see if you can decode it. You get an encoded matrix. So you get one that's not 0 to 26. One that has negatives and big numbers, and you have to somehow get it back to the original message. Somehow. There's math for that. Priscilla?
Are there going to be any like minors and cofactors?
Nope. However, you are going to have to find at least 1 to 2 determinants of bigger things by hand. So you have to use the cofactors. Does that make sense? Okay. All right, cool kids. I'm going to mark down attendance really quickly. Sam is the only one gone. Yeah, and then Tyler was excused tardy from Mrs. Kendrick. You guys, if you need a book, come up and grab one, although we have like 3 minutes left. Do you guys want me just to show you the book? I guess you can get the first couple review ones done. There it is. Do you have to write the directions or the problems? The answer is no. Do you guys have any problems in 1 through 8? 2, 7, 9. There's 2. There's 7. And there's 9. There we go. Hey guys, on number 7, although he's bigger than the one you'll have on the test, the one you'll have on the test will be more like this size. But if you needed to solve this system of equations, this is section 8.1, right? We would get a 1 by, how do we get rid of a 5 if we want it to be a 1? Divide, 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 divide. Once we get the 1, how do we get zeros in the 4 and the 9 spot? Negative 4 times plus, good. Or negative 9 times plus. But if you were allowed to use your calculator, the whole thing and then RREF. Yeah, RREF, and it would take you straight to the end. There is going to be a little small one on the by hand, but then there's going to be a bigger one where you can just use RREF to do all the work for you. Do you guys have any other questions about the test tomorrow? I don't think so. You're going to bring your calculator all nice and charged up, right? You're also going to be ready with things like formulas just in case. What did I not say? I don't think I said Kramer's rule. I know, it would have been easy. I think you could technically use Kramer's rule to like solve a system of equations, but I think it might be easier to use REF or RREF. Oh, remember I was just talking about RREF, and I said there's going to be a little one by hand on the non-calculator, and then a bigger one that you're allowed to use the calculator for. Yeah. All right, guys.